Hey, welcome! Today, we are diving deep into one of the biggest mysteries out there, a story about the invisible forces that might have literally built our entire universe. And it all starts in the very first moments after the Big Bang.
So, at the very heart of this is a classic chicken or the egg problem for cosmology. We see these huge, powerful magnetic fields in galaxies all over the universe. But where did they come from? Did the galaxies form first and then kind of spin up these fields on their own? Or was there something there before the galaxies even existed?
This splits scientists into two main camps. You've got the galaxy's first idea, which says, stars and galaxies get going, they start spinning, and that motion generates magnetism. Pretty straightforward. But then there's the magnetism first theory, and this one's a bit wilder. It suggests that a faint magnetic field was already woven into the fabric of the universe from the get-go, acting like a cosmic blueprint for everything that came after. To figure out which one is right, scientists have had to become, cosmic archaeologists. They're not digging in the dirt for bones. They're on a massive fossil hunt for the oldest, faintest traces of magnetism in the entire universe. It's like looking for a ghost from the dawn of time. And the fossil they're hunting for? It's called a primordial magnetic field. Now, don't think about the magnet on your fridge. We're talking about something incredibly weak, these ghostly magnetic traces that would have filled all of space just moments after the Big Bang, long before a single star ever lit up. Okay, so how could a phantom force like this actually build a universe? Well, if that magnetism first theory is right, these fields were basically the seeds of everything we see today. To get this, you have to picture the baby universe. It wasn't this beautiful tapestry of stars and galaxies we see now. No, it was an almost perfectly smooth, incredibly hot, dense soup of particles, just expanding everywhere. The key word there is almost. And this is where those primordial magnetic fields would have been a total game changer. They would have acted like these invisible seeds, creating tiny little imperfections. Think of them as microscopic ripples in that otherwise smooth cosmic soup. This was the very first hint of structure in a universe that had none. And those little ripples changed everything. They created patches that were just a tiny bit denser than the areas around them. And that was enough to act as anchors for gravity. It basically gave gravity a head start, a foothold to start pulling in gas and dust, clumping it all together into what would become the very first stars and galaxies. I mean, without these magnetic seeds, the universe might have just stayed a boring, uniform fog of gas forever. So that's the theory, and it's a fascinating one. But how on earth do you find proof of something so ancient and so ridiculously faint? Well, let's get into the hunt itself, the search for the Big Bang's magnetic fingerprint. This quote just nails the challenge perfectly. Astronomers really are like paleontologists, but instead of using bones to piece together a dinosaur, they're using magnetic fossils to piece together what the universe looked like when it was just a fraction of a second old. It's incredible. This whole cosmic fossil hunt really comes down to two main clues, two major lines of investigation. First, they scan the oldest light in the universe, the actual afterglow of the Big Bang. And second, they look in the absolute emptiest places you can possibly imagine, the great cosmic voids. All right, clue number one. This is the big one. The cosmic microwave background, or the CMB. The best way to think about it is as the baby picture of the universe. It's this faint glow of heat left over from the Big Bang that literally fills all of space, even today. So because this is the oldest light we can possibly see, it's packed with clues from that ancient time. If those primordial magnetic fields were there, they would have actually twisted this light in a very specific way, leaving behind a subtle pattern. Finding that pattern in the CMB, that would be the smoking gun. It's like finding a perfect fingerprint at the scene of the crime. Now for the second hunting ground, which is almost more poetic, the great cosmic voids. We're talking about these unimaginably huge, almost completely empty regions of space that sit between the giant web-like filaments of galaxies. So why look in the middle of nowhere? It sounds a little crazy, right? But there's a brilliant reason. These voids are the most pristine, untouched parts of the universe. There aren't any galaxies inside them churning out new magnetic fields. So that means any magnetism we could detect in one of these voids has to be a true fossil. It couldn't have been made recently. It has to be a leftover from the beginning of time itself. Look, this whole cosmic detective story is way more than just a cool puzzle for astronomers. Finding these primordial magnetic fields, or proving they exist,
That would fundamentally change how we understand the entire universe. Finding these fossils would prove that magnetism wasn't just some byproduct. It was a fundamental architect of the cosmos. The strength and shape of these fields could tell us what was happening in the first yoctosecond. That's a trillionth of a second after the Big Bang. It would get us one giant leap closer to the holy grail of physics, a theory of everything that unites all the forces of nature. And that just leaves us with this one profound final thought. We're surrounded by magnetism every day, but we might just be living in the echoes of a force that literally set the stage for our existence 13.8 billion years ago. So, if magnetism truly wrote the first chapter of the universe, what other secrets are written in its invisible ink, just waiting for us to read them?